Okay, a couple years back, I found this really cool website, and it has all these interactive animations made by Flash out of this, I think, University of Colorado. And it dawned on me that it would be really useful, but it really needs some explanation instead of me just giving you the link, kind of explaining what's going on here. So, what you're looking at is a container carrying, withholding a group of molecules. Over here, I can change it to atoms of neon, argon, oxygen, and you'll notice that they're in pairs because oxygen is a diatomic um, molecule, and water, where we have molecules of H2O. And so, also on the right here, I can click solid and put it in the solid state, and you can see that the molecules are close together. They're in a particular lattice um, shape, a particular um, arrangement because of the polarity of the water molecule. That might be beyond what we're talking about in middle school, but it's a solid, and you can see that it's very tight and they're vibrating. And now when I change it to a liquid, you'll see that it's moving a lot more freely. They're still close together, but no particular arrangement. They're just kind of scattered, and uh, and they're moving back and forth past each other and around each other. Some, kind of trying to escape. And then finally, as a gas. And you can see that they're just moving freely, bumping into the sides of the container, um, trying to get as much space as it can, right? Trying to escape the container, just trying to move because it's so full of energy. At the bottom here, we can heat things up, and so because it's a gas, it already has a lot of energy, and if we add heat energy to it, it's going to increase its kinetic energy, which means that it's going to move a lot faster. And so I turn up the heat, and you can see that these molecules of water vapor are really moving fast, faster and faster. And then, of course, if I ice it down and cool it down, you'll see after a time that the molecules will slow down, it will lose its energy and start to become slower and slower and slower, and eventually the gas will turn into, it's happening really slow, the gas is going to eventually turn back into a liquid. There we go. And then now it's turned into a solid because you can see that it's made its arrangement of molecules, and it's only vibrating. Now the interesting thing here too is that if I keep cooling it and taking its heat energy away, I'm taking away its kinetic energy, and its movement, its vibrations become less and less. And if you look at the temperature scale here, it says 4 Kelvin, and if I get to 0 Kelvin, that is the theoretical number of absolute zero. And when I reach 0 Kelvin, here it comes. It may take a while. There's 1, and at 0 Kelvin, there should be absolutely no movement, and that is what absolute zero is supposed to. That's what's supposed to occur at absolute zero, where there is no kinetic energy with the atoms at all. And of course, that's a theoretical temperature that's never been reached. Um, so I thought this was kind of a cool example and visualization of how um, molecules and atoms move in the different states. So again, I can change it back to a solid just by a click, and you can see it's in that arrangement because it's water. If I change it to like neon, you can see very tightly packed, organized. And then I'll change it to a liquid, neon. Okay, so there's a lot more movement. It's not as in a structured arrangement. And then finally, as a gas. All right. I hope you enjoyed it, and I hope you watch the next one that's going to talk about pressure and heat as well as just the arrangement of the molecules. All right, thank you.